Is anyone here a developer? Excellent. All right. So that will leave like 3 people that aren't. I'll just let these people come in as well. Is anyone here developing specifically for mobile? Like 3. Okay, that's cool. So that means the rest of you, what kind of development is it? Do you do like Windows platform stuff, PF, or is it any XAML experience? Yeah, a little bit? Okay, I'm just trying to get a gauge for where you guys are at. So this session is on adaptive UX, which is a really, really cool feature of Windows 10, which is why you need to use Visual Studio 2013 and everything. And it's, let me just try and get this running. Adaptive UX is a way of SLC, it's a way of trying to solve several problems. One of those problems is fragmentation. So does anyone have an idea of what I'm talking about when I say fragmentation? Yeah? Well, just give me an example.
Well, to me, it's like iOS has a different code base to Android, has a different code base to Windows Phone 10, has a different code base to Windows 10, has a different to Windows 8.
Okay, so fragmentation to you is different languages, different code bases for different platforms, different UIs, everything. Okay, so that's one issue for sure. And by the way, please ask questions. Raise your hand. I can see all of you, I think, despite the light. But I really want to encourage questions if you have anything during it, even though there's a Q&A session at the end. Fragmentation to me is absolutely horrible. It's really, as a developer, it's the one thing that you go, oh, especially like you said, if it's something to do with clients that want to have the same app on multiple platforms, such as you can use Xamarin for that. It's a good tool. This talk is not about Xamarin. This talk is primarily about Windows 10 and what the promise is, I guess. Anyone want to take a guess on what this is? If you saw this picture on Twitter, I had a couple of guesses. Yes? Different screen sizes? That's one aspect of it, I guess. Sorry? Resolution, yeah.
Spread of devices.
Yep, that's even closer. For? Android. Yeah, exactly. So this is it's a visual representation of the most used Android devices. So I don't know if you can see that little square down the bottom corner. That's the smallest they made it to this image, because there's tons. Like there are so many Android devices. And has anyone here developed for Android? Yes? And you're not rocking in a corner. Very good. Excellent. You made it here. It's not a nice experience, in my opinion. You can use Java. Sure, Java's pretty good. And you can use it to target, billion of devices. Yes. But in fact, this is now the current, this is August, but the most current representation of the different Android OSs that are used by consumers. So I don't know if you can see it, but there are, if you have a timeline as the end, so there's 1, 2, 3, 4, 5, 6, 7, 8 different OS versions running on Android, right? And all of them have different APIs, and what happens is that then vendors, because Android is open, vendors go and go, I'm just going to do my own tweak on it. Something like Chrome, for example. So Google Chrome will work on Android, but version something will only work on version 4.4 if it's from this vendor, and only version 28 will only work on Android 5 if you're with, it's really, really complex. And as a developer, you've got to take all this into account. And how the hell do you do that? There's no easy solution. And then what happens is that then you look at screen sizes, like you were saying before. Screen sizes. These are the current Android screen sizes. This is taken from, it's an app called OpenSignal, and they monitor and they keep track of where their customers are coming from. So OpenSignal, you can find basically mobile signals all over the world. And if you had the interaction web version of this where I took the screenshot, you could actually hover over all these and get all the different screen sizes, and there are thousands. And there are different resolutions for different physical sizes. There's even a 21-inch Android device of some description. And I mean, now we're into almost like TV size, and you still have to deal with it with one code base in Android. Holy moly, I can't swear, I'm being recorded here. So Android, are you still developing for Android? Yeah, kinda? How do you mitigate this? How do you manage? How do you test? No, exactly, you can't. Like you can maybe get 4 or 5 phones if you've got some budget for that and test on those devices, and then kind of have to do, right? I mean, to be honest, there are now 24,000 different Android devices. That's a lot. That's a lot of devices. And these are, individually, specific models that have been identified. So 37% sure is Samsung. So that's your Galaxies, your Galaxy Notes, and all those. So you can choose to just target those. But then you're still missing out on 62% of the market where you just hope it works, right? And that's 1,300 brands. So it's an absolute nightmare. You're going to have to sort to something like, there's services now popping up such as, what's it called, the AirPlay, something like that, where they actually have physical devices and you buy time on these devices. That's the madness we've gone to. You have to buy services that have physical devices connected to the internet that you can then test on. Now, guess what this is? Come on. Yeah, exactly. So Apple don't go into all that mess, right? They do it nice and simple. It's pretty cool because you have, I guess that's your iPhone, what's it called? XL, big, fat, whatever it is.
The 6 plus the
Plus, that's it, thank you. Yeah, and then you get the iPad, your iPad mini, well, actually it doesn't have the iPad Surface on there because the stats are from August. So, but it's really simple. And as an iOS developer, anyone here develop for iOS? Wow, really? Oh, okay, I can then tell you that developing for iOS, you don't have all these problems. You either target iPhone or iPad or both, and you generally have 2 different solutions for it. I don't do Objective-C, but again, you can use Xamarin. So, now we've got Windows 10, or the way I like to look at it is that this way, Windows 10. Anyone know the unicorn? Yeah? Don't be so quiet, people. Jeez. So Windows 10 now, you probably heard it wants to target phones, tablets, desktops. They want to do IoT devices, so some of them don't even have a screen. They want to do Xbox. It's coming very soon. I think it's March has been announced as the update date for the Windows 10 Universal Platform Edition of Xbox. And then, of course, HoloLens. And Microsoft wants you to use the same tool set for all of this. So how do we how do we not end up in the world of Android, but still having all the Android goodness of various screen sizes and different vendors and choice, and not having to go down the Apple way of being extremely restricted of what you, of the devices you have, and Apple telling you which device you like. So Microsoft have come up with this idea of the Universal Windows Platform that will work across everything. But then this session now is, obviously about how do you develop for all of these different devices. Because in fact, I don't know if you recognize any of these names, but generally Windows devices, or Windows Phone especially, have been associated with Nokia. And they brought, Microsoft bought the Lumia brand. All of these are in fact Windows Phone brands. And they're mostly, obviously, sold outside of the US. But there are a ton of them. There's a lot of Windows Phone devices, and they're starting to have the same issues as Android. So Windows 10 is here to save the day. Here's a Windows, Microsoft slide of Windows 10. So you have the phones, the tablets, all of this stuff will need to use, in some way or another, the same code base, and in the same design to some extent. So, do you recognize the problem? Like, I'm trying to paint a picture of what we're trying to solve, right? And not forget the Surface Hub. Have you played with the Surface Hub? 100 different touch points. It's absolute madness, and you get 2 people doing the same, using it at the same time. And it's basically a massive, massive surface, the 84-inch surface. Okay, Universal Apps. So Universal Apps are, the solution, I guess, to what all this is. You use Universal Apps to write for, or to publish and develop for the Universal Windows platform. And it's really confusing because the name has changed so many times. But they're now called Universal Windows Apps or Universal Apps. And they run on the Universal platform or Windows platform. It's Windows 10. It's a bit confusing. I don't have a pointer here, but down in the left-hand corner, it says Adaptive User interface. So that's one of the pillars that we're going to look at today. The others are there as well, and I'm sure you all heard of cloud and all that stuff. Natural user inputs is how you use your finger to do stuff and touch and all that sort of stuff. One SDK and tooling, so that's Visual Studio, as we'll hopefully look at in a minute. Yeah, looked like it worked. Hooray. And there we go. So why am I here? Because I talk a lot about this stuff. And then if you're really loud, Microsoft gives you a sticker that says MVP. And I love this stuff. It's kind of like what I do. So I've done some Pluralsight courses. If you don't know Pluralsight, they have a stand in there. Very well worth checking out because there's an enormous amount of learning material on their site. Even get your company to pay for it. I'm sure they won't mind, forking out $29 a month or whatever it is. And I do a podcast where I also talk about all this sort of stuff. So that's kind of why I'm here talking about it. Okay. Let's go. Right. So any questions so far? Wow. Really? So you got everything. Very good. Okay, adaptive interfaces. We'll talk about some of the theory behind what's involved, and then I'll try and run some demos, which apparently I'm running off my Surface now, but that's okay, we'll do that. So has anyone here developed universal apps for Windows? Windows 8? There's a couple of people. So you basically you kind of had one project that ran on both phone and tablet or desktop. So now it's called Universal App again, and it has nothing to do with what it was before. Again, really confusing. Just bear it in mind. Universal App for Windows 10 is not the same as Universal Apps for Windows 8. It doesn't even use the same binaries or anything. Like it's completely different. Also, if you have a Windows Phone 8 or Windows 8 app and you want to upgrade it, you have to do it pretty much manually, copy stuff across between the solutions. So it's that different. One's Windows 8.1, one is Windows 10. We can now have resizable windows. You will not believe how many people thought it was stupid that it was only full screen, and this is now one of the top things that sells Windows 10. Hey?
It's Windows. I mean, if you don't have Windows.
Yeah, well, I agree. But it's, I would argue, not people here, but most consumers would do one thing at a time. But it was a big deal. So I'm happy it's there, for sure, because I use it all the time. Portable class libraries is what you used before. So PCLs were a way of having common logic in a business layer, and that got compiled into the solution, Windows or Windows Phone, that eventually got pushed out to the consumer. So it was sort of like it was a shared project, and it didn't actually have a DLL. It was where you had common code living, but you were restricted by choosing which platforms you were targeting, and it was a little bit clunky. It still works, and you still do it in Windows 10 if you're comfortable with it, but now you use XAML and portable class libraries, and it all gets compiled into the single solution for Windows 10. Windows Runtime is sort of what the Windows 8 apps were using, which is why you can also use JavaScript and HTML to develop for them. Now there's Core API, which is, I guess it's a contract between Microsoft and developers saying we will always provide this level of APIs for you no matter what you develop for Windows 10. So if you're doing HoloLens, you'll have the Core API. If you do IoT, same thing. Service Hub, all of it will have these specific APIs, which is fundamental to the universal platform. Which is a big thing. So we can do a whole talk on Core API. As I said before, Windows 8.1 had one binary per target, which was, you had to publish things multiple times, right? And you had different developer portals. If you're a phone developer, you had one portal. If you're a Windows developer, you had another portal. Now you get one binary overall for Windows 10, and everything lives in there. And then I'll get into this in a minute, but .NET Native. Have you heard of .NET Native? Is that a thing for anyone? No? Okay. It's probably not going to affect you too much in terms of development, but it is going to affect your users hugely. So, as it says, it's a pre-compilation technology. So it's a way of turning your code directly into Windows 10 code. So normally you would have .NET go to an intermediate language, and then it will be compiled as you use it on the device, right? So there was this, it's almost like a Java thing, just-in-time compilation. So there would be a much more optimized way. So whether you were writing in C# or VB or whatever your language of choice was, it would be compiled into the intermediate language, and then it would then be deployed to the device, and you would then, the runtime on the device would then turn it into native code. So now we skip that middle bit. So everything is compiled into native code, which is good, except if you're a developer, to some extent, because you don't want to develop with this because it takes about 60% longer to compile. So, hooray! If you run it in debug, it still does the old trick of going to intermediate language. So it's still the same fast developer process. But everything that runs on a consumer device is .NET Native, which is really good. Like, it makes everything a lot snappier. So for developers, you get performance. You can still use C#, you can still use VB, you can still use all the same APIs, whatever it is that you used before. There is no difference in that. And it's still .NET. It's still the same MSDN documentation. It's just the way that it gets compiled and goes on the device. And it sounds like it's just you just say it as almost a nothing statement, but it's a huge achievement. Again, a whole talk on .NET Native. And then for users, which is all they care about, it's fast, low cost as in memory. It really is optimized for the device straight off the bat. And hopefully it gives them a much better experience. That doesn't mean you have to be lazy though, right? You still got to write good code. It doesn't do that. Okay. Any questions so far? I'm going to keep asking until someone asks a question. No? All right. So one of the issues, well not issues, one of the challenges I guess with having same code base running on so many different devices is the Android conundrum, right? You have thousands of different screen resolutions, potentially. So there's something called a scaling algorithm, and it's relatively basic, but as far as I'm aware, it's a bit of a trade secret what the actual algorithm is, because they've abstracted everything to make it easier for us. So the idea is that if you hold up a phone, so I've got a phone here, and if I hold that up, I usually hold it like this, right? That's about as far away as I am. And most people are the same. You don't normally sit down unless you forgot your glasses. But if you have a laptop, you're like this. You sort of stand here, and you see that the distance is about twice, or thereabouts. And if you're sitting in with an Xbox, well, you're probably even several meters away because you're sitting with a TV. And to take all that into account, they sort of come up with a scaling factor. That means that it knows what device you're on, so the code knows whether it's a phone or a tablet or whatever. And the UI is scaled to suit that device. So that means that you are then talking about effective pixels. So a device might be 1920 by 1080, or it might be 800 by 600, or it might be a 4K TV, or anything in between. It doesn't matter. As far as you're concerned when you're a developer, you just use effective pixels. And effective pixels is sort of a generic pixel measurement. And then once it's deployed to whatever device it's on, the framework knows what size it needs to be. So we have, for example, a phone, and it would show up as 100 by 100 pixel size. On a tablet or a desktop, 150 by 150, and on a larger screen, 200 by 200. And that means that it looks the same no matter, because the distance is different. It means that it looks the same. Is there a question?
So are we talking about the physical size of the screen?
Yes. You're talking about physical size combined with resolution. So that's what the scaling factor means. So
You're taking into account the physical size when you calculate the effective pixels?
when you, sorry?
When you calculate the effective pixels, input to the algorithm is the physical size of the screen?
See, that's a really good question. Do you take into account the physical size and the resolution when you calculate effective pixels? Here's the good bit. You don't have to calculate effective pixels. But the algorithm, yes. Yep. Yeah. Every device has a scaling factor that it'll know about. So this means, as a developer, suddenly we're not dealing with the whole Android thing from the perspective of designing the UI. There's still other challenges, which we'll come to in a minute. But in terms of visual representation of something on the screen, the framework will do all that for you. Does that make sense? This is good. Woo! No? Boot. No. And then also you have a guideline of expect a phone to have about 320 effective pixels. So when you're designing your screen in Blend, which I would recommend, we'll hopefully have a look at that. Tablet size and that sort of thing has about 720, and the larger screens is 1024. And if you go with that, then you're pretty sure that's going to work on everything. I mean, there's always edge cases, of course. And then the other thing is if you design everything in multiples of 4, you make sure that it scales without distortion. So if you have, if you make something 100 width, well, it's a multiple of 4, right? That means that it can be scaled appropriately. But if you made it 110, well, it's certainly no longer a multiple of 4. So if you had a device, it might look 1 pixel off. So there's still some considerations to be done, but it's a hell of a lot easier than developing for 1,000 different screen resolutions. That make sense? Cool. All right. Responsive design techniques. So this is fine that the effective pixels is going to solve your design conundrum initially, but there's still other things that may need, that doesn't fit with the design. So there's 6 different ways that you can sort of design for responsiveness or create the adaptive UX that you're after. I've got some examples here. They're straight off MSDN, so if you want to read more about them, that's where they are. Reposition. So on a phone, you might have something that follows vertically, so you might have one element after another. When it's on a larger device, then you might want to have it next to it. A good example is it the Mail app? I'll show you the Mail app in a minute, and I'll show you what I mean. So reposition is one of them. Resize. So if you had a reader app, like a newspaper type thing perhaps, you might just want to fill the gap with, if it's just text. But then you let the framework resize to whatever device that you're on. So we probably use that in most things. If anyone here does web development, we do that a lot. We just make it fill whatever's there up to a certain width usually. Reflow. So that's sort of the same ballpark, but you have content that may span multiple columns, and then you sort of just make them flow underneath. So you've changed the flow of the page, and you make it similar to the first one with the reposition, except it's the same element that may just flow on. Reveal. So for some device sizes, you might have a navigation that makes sense on one size, but not on another. You can use reveal to hide certain things. And all this is part of the XAML. We'll look at some of these. I don't think we're looking at reveal. And reveal additional elements if it makes sense for that particular platform. And this is all done, by the way, most of this is done in screen size. So you don't actually care if it's a phone running Windows 10 for mobile, I think is the correct term, or if it's running Windows 10 on a tablet. You can have a 6-inch phone and a 7-inch tablet, but they're different operating systems, essentially. It's still Windows 10, both of them. They still run universal apps, but you might want, depending on screen size, your app looks different. So you don't really care whether it's one or the other. You just care about what the screen resolution is. I guess that's key. And then we have replace. So in this case, on a phone, it might make sense to just have the menu items coming down the main area of the phone. But if you look at a tablet or larger device, that will look silly, right? It would be massive, huge, long buttons. So you might want to replace that navigation with a different element. And then there's always the re-architect one, which does tend to be used a fair bit because there are certain scenarios where it just doesn't make sense to have this exact same UI. And in this case, as you can see here, on the right you've got the tablet version or the larger version, and it has 2 different elements. In the re-architected version for the mobile device, it just goes to one page, and when you tap on one of the elements, it then navigates to the second page instead. So there's ways of doing that as well. All right, how are we looking time-wise? Very good. Okay. Let's have a look at how we can build some things. So, any questions so far? Does this make sense, sort of what the thought process is? You design in pixels, and pretty much everything, yeah?
HTML5 and Bootstrap is already doing all the things, whatever the response free flow and all those things. So
So the question is, if you can already use HTML and CSS and JavaScript to build Windows apps, so why don't you just use that with Bootstrap, for example, and use the responsive goodness, I guess, that comes out of that. And you can certainly do that, absolutely. This is just a way of doing it in XAML, which is what a lot of, I guess, mobile developers are used to. And there are some things you can't do with WinJS, which is what you're doing. I'm building an Xbox app at the moment, so I'm learning a lot about WinJS. And there are just things that performance-wise it just doesn't do. It's really good for a lot of stuff, like Xbox apps. But this is another way that you can, I guess, use the responsive design for using XAML and C# rather than HTML and CSS. But you can certainly do that as well. I'm not sure exactly how many of these techniques come out of the box, but you can definitely do that. It's just more tools. Hey. Anyone else? Cool. All right. So, by the way, if you do need it, Visual Studio Community is free, and that comes with all the goodness. Just don't forget to tick that box that says Universal Windows Apps Development Tools. That's where all the emulators come in, that's where all the SDKs, and they keep updating it, which is why my machine crashed this morning. They keep updating the SDK. So you're constantly getting new goodness. Windows 10 for mobile is not out yet, even though they're selling devices. So they're still not completely done, I think, but it's very close. So that's the way to get the tooling. Okay, the relative panel. So this is one of the fundamental ways of I guess, organizing your content. And it's very similar to how you would do it with an HTML table, in fact. So we'll just see. Hey, there you go. So we'll look at that in a second, that code. It's all XAML. So is anyone here not familiar with XAML? XAML. There's a couple. It's extensive application markup language. It's the way that you traditionally have built Windows apps and Windows Phone apps from the UI, or your view part of the MVVM paradigm. And it's just an XML syntax. So if you know XML, you should sort of be pretty familiar with it. But it's very powerful. It does have an enormous amount of functionality, and which is sometimes it gets you in trouble because you can do so many things with it. This is the relative panel. There's 4 rectangles, because this says rectangle. There's a red, a blue, a green, and yellow. And when you run this, it's kind of looks like this. So I'll just see if we can. All right. Now, first, I just want to give you an example of what this all can look like. So, see if I can get this right. Hey. So, this is my phone. So I'm scrolling here, and you can see it as well, right? This is Windows 10 for mobile, running on my very, very low spec Lumia 630 that's a couple of years old. So that's a good thing. It's pretty responsive. I'm going to tap on the Outlook mail, so that one. Oh, I actually didn't want to move it. So there's the mail client. Now you can read my emails if you want to. This is a responsive app. So this is done using what we just talked about. So this has here, I'll just open this as well. There we go. If you tap on an email, so I'll tap on the top one, it then loads, and it just goes into the email as you'd expect, right? So I can resize it, I can look at all of the new Xamarin 4 goodness that's come out, and if I tap back, I just go back to the same screen as you saw before. Like nothing really revolutionary, is it? Pretty simple of what you would expect. You have the new things set flag. If you sort of drag it left or right, you can delete them as well. And you got the same functionality with the checkboxes and everything. No jaw dropping yet? Okay. So, if I then look at the desktop version of it, it comes, there it is. Obviously, I've got a new email here. So this is running on the Surface. If I then tap on the same email, it just opens next to it. Right? These two applications are the exact same binaries. There is no difference. It's the exact same file that you download from the store. It's the same development project. Everything's the same. But they look quite vastly different, right? Kind of like what gives it away, though, is that if I resize this, just close that. Don't need that yet. See, suddenly, as soon as I get to a certain size, I get the phone experience, right? But as soon as I scroll out here, it changes. And you can see the left-hand side panel here as well is collapsed. But as I make it bigger, suddenly that comes into play as well. So all of these triggers is based on size of the window that it runs in, as well as the device it runs on. And again, you get the same thing. If you, whoops, don't want to do that. If I drag with my finger here, you can see it's exactly the same thing. There's no difference. Yep. The breakpoints? We'll have a look at that in a minute. You can set up your own, for sure. Yep. It's the whole idea is that Microsoft wants you to use your design. Like, they don't want to mandate how your application should look. Sure, they give you design guidelines and directions, and they prefer if you follow most of them. Like, they prefer that you have a hamburger menu, as it's called up here. They prefer you have that rather than some other icon. But there are certain designs that maybe mandate that you have the word menu on there. So you can change things around, but certainly there are things that they would like you to do, but nothing is set in stone. Which is also, if you open up the Windows 10 projects, templates in Visual Studio, you only get the blank and the test project, and there's no, here's how to use this control, because they don't want you to, they don't want in the store, for instance, to have a million apps that look the same, but they also don't want to mandate what you should do with the different controls. Does that make sense? Yeah? Anyone else? Just yell out, because I might not notice you. So that's the relative panel in action, among other things. So we'll just see if I can bring it up here. Okay. Still? Yeah, still not. Good. So, where we go? Presentations. Relative panel. Okay. Unavailable. That's disappointing. All right. Give me 2 secs. Demo goes on with me. So, right, now Visual Studio is still very broken. All right. So, if this would work at all, install missing features, right, so that's not going to work. Okay. Now, this is really annoying because Visual Studio is broken for me. But that demo, I'll just try and go back here. We'll just have a look. Here. I'll just talk a bit, because that's what I was going to show you, right? If you, I don't know if you can see it. I don't have a pointer, which is kind of annoying. Can I point here? Does that work? Hey, kind of works. So the red rectangle and the blue rectangle are just in the top left. Then when you put in the green, it says relative below the red and a line left of red. So that means it's always going to be below the red, and it's always going to have the left alignment with the red. So it's just reading it as it is, essentially. But then it also says a line right with the blue. So if I were to change the size of red and blue, the green would follow. Does that make sense? The green would expand and have the same size underneath. And then you have the yellow one, which is underneath again, and it says always below green, but a line left with blue, and a line right with panel. So it's always going to fill the gap, no matter how big a space you've got. So the relative panel is a way of positioning elements and make sure that they're always aligned with each other, no matter what the user's doing. Because remember, a Windows 10 app now can be in a window, and they can size it to whatever size they want. There's no rules on that. So even though you're on a very, very large screen, they might run it as a mobile size app. Okay. Huh. Don't know if this is going to go well. Okay. So Apologize for that. The next thing is visual states. So this is what you were talking about before. Lady at the back. Can you choose yourself when these triggers are happening, or are they set in stone? So visual states, the most common one is to hide or reveal something based on what the dimensions of the elements are. So the dimension of the screen based on what the elements are set to. And this is the way that you could do it in Windows 8.1. So this is probably familiar to many people. Have something and then say if size is something, or otherwise if size is something, and then you set the state. It's really brittle because what happens when you want to introduce a new state, you've got to go change this absolutely everywhere. And it's kind of like you don't, if, else, it's just, it feels clunky, right? And it's all set based on, magic strings and, what's my state and all this. So it's really not pretty. But that was the way that you had to do it. And you had Visual State Manager .go to state, or go to. So if anyone used to do this for Windows 8, that's probably familiar. So just in comparison, this is now how you do it now. You just have a visual state, tag in XAML, and you have an adaptive trigger. And in this case, the adaptive trigger is based on window width. So it says, use this state if the minimum window width is 501. So, okay. It looks like we actually got somewhere here. Sorry? Light switch? Oh, Silverlight. Are you saying light switch or Silverlight? Yeah, well, Silverlight, as bad as a name as it got, was actually, it was a really, really cool technology. And the people that were into it and really got the hang of it, it was immensely powerful because it was sort of like the best worlds of should I say Flash? It's a bit of a boo-boo word now, isn't it? But it had that whole plug-in feel of it that Flash had, but it also lets you run desktop apps in the sandbox. But it was XAML. Silverlight was absolutely XAML. And the first Windows Phone version, the 7, was based on Silverlight as well. So you're absolutely right. It does. It all stems from those days. Although Silverlight was a subset of, what was it called? It wasn't WPF. It was the other one. It had some other name as well. Okay. Let's see if we can get this working. So let me just change back because it apparently decided to load now. Hey, so there it is. So this is the development experience, I guess, in Visual Studio. Can you read that, or do you want me to make the font bigger? I mean, the bottom bit. Is it okay? Yep. Yeah? Up the back? Yeah, all right. Okay, I'll just yell out. So you can change the design surface here, and you get all these out the box, because they're sort of like the most common, I guess, generic ways of representing the screen size. So if we do like an 8-inch tablet, as you can see, this is what I was explaining before, the yellow now goes out and sits at the end, right? And the same is if we change the design here, we flip it to portrait mode, it keeps just filling the space. And let's see if we can run this just for a bit of giggle. And again, so this is debug, so now I'm not running .NET Native. It doesn't compile to .NET Native because every time you hit F5, it would take longer. Yep. First deployment always takes a bit longer. So just while we wait, can I just ask, does anyone here actually, are you looking at developing for Windows 10? Anyone? There's a couple. All right, what kind of apps are you doing? I'll choose you just because I saw you put your hand up. What kind of apps are you looking at building? To drink better. Okay, no, that's not a bad idea. I'm assuming that doesn't mean drink more. Drink wisely, maybe. But could you see yourself using any of this sort of responsive techniques? Or would you, let me rephrase that. Would you target more than one device family? Would you go for phone and tablet and Xbox? Probably not. So there's an example of, just focus on mobile. Yep. But what if you, for free almost, could make it run on a tablet? You know, that's kind of where we're trying to where we headed. One point, a bit of an aside, but Windows 10 runs on all these things, right? I don't, just like you were saying, I'm probably just going to target one device family. So you may be asking, okay, well, why would I use Windows 10 then? What's the idea of me as a developer, which I'm assuming most of us are, as we saw at the start? Why would I pick up XAML skills and Universal Windows Platform skills and all of that? Like, I'm probably just going to target one device anyway. But the whole point is that when you have these skills, because of the core API, suddenly you can develop for any of them. So your skill set now, with one time the effort, gives you 5 times the devices that you can develop for. So you don't have to relearn developing for a phone rather than a desktop device or an IoT. Of course, there are things that are specific for those individual platforms, but the actual core of it, you all have. Does that make sense? So I think the Windows Universal Platform is more about you being able to develop for many, many, many more scenarios and actually informing your customers of what the opportunities are, rather than having one app that runs on everything. I'm doubtful that will ever happen, that you'll have an app that runs on IoT with no screen, as well as HoloLens, as well as a phone. It seems a little bit far-fetched, but I could be wrong. Sorry, did you want to add something?
I was just going to say that as a developer, I don't see a reason why I'd make my app on more than just phone, but my users may want it on tablet.
Yeah, so that's a good point. You're saying, well, it might not be as a developer, you think, well, it's just a phone target market, but users may want to run it on something else. And it might be they want to run it on an Xbox for whatever reason. Although that would mean that you would have to maybe think about how it looks on a larger size screen. But as we saw, it has, there's less to do to facilitate that. Anyway, I just thought that's an important point, that you get a lot for free if you decide to invest time in this. Anyway, so our relative panel here, you can see it decides to resize the way that we expected it to. And depending on time, what have we got? Oh, we got time. I can actually change these. So if I now go in and, it always confuses me to put this at the bottom. So here's the code we saw before, right? If I change, say, the yellow, where's the yellow? Here, yellow rectangle. Align left with red. You can see it's a little bit small, obviously, because I just resized everything. But you can see the yellow now moved to the left, right? It really is that simple. Now, of course, you're going to have scenarios where clients go, oh, but I want it also to dance and look like Batman or something. There's going to be some scenario where you go, oh, well, I can't do that. And that's where maybe your business value come in, and you can actually advise on what these things are meant to do. But in essence, the relative panel, that's what it's about. It's about aligning things so that no matter what device you're on, they are always going to align and look the same relative to each other, hence the name. Okay. All right, we're looking at adaptive triggers. So let me just see the next. Yeah. So I'll go straight into the demo for the adaptive triggers. So we'll just try this. So this is, again, remember I said at the beginning, or somewhere, that universal apps don't equal universal apps? It's really easy to get confused, because that says universal there, and that says universal there as well, right? And they're not the same. So if you choose Windows Universal, that's your Windows 10 project. But if you chose Windows 8 Universal, then you get Universal Windows 8. It's really confusing. I've been caught out a few times doing this. Windows Universal, happy days. Okay, so we're going to start that. What's this saying? Re-enter your credentials. All right, let's see what happens. Sure. So while that creates, it sets up all everything. Okay, so this is what you get. Solution Explorer. Now, you can see this, or do you want me to try and make it bigger? Is it okay? I'm just very conscious that there's people at the back here. This is what you get. Very basic, and this is the whole idea. We don't want to have it filled with, if you're ever developing for Windows 8 or Windows Phone 8, you got this massive amount of stuff, and the first you did was delete everything. So you had localization, and you had logging, and there was a bunch of things that you really didn't need. So this is about as bare bones as you can get. So we have our main page here, and it's very exciting because there is absolutely nothing in it, if it'll ever load. Okay. Does anyone here, are you familiar with Blend? Couple people, yeah, Blend. You can do all the design in Visual Studio if you want to. There's a toolbox over here, which will load, and it has all the different elements here, and you can drag them on. You can do everything in Visual Studio, and some people prefer it. It's not a bad experience, but I prefer to go up here and say Design and Blend, and there it is. Blend is, it's kind of like a mixture between, I guess, Photoshop and Visual Studio, and it's supposed to be the design view of Windows apps, and I guess where I came from when I first saw this, it was a way of letting designers have absolute control without stepping on the developers' toes. They could do all the XAML stuff without ever having to look at code. And the same for the developers. They could look and do all the coding and just know that there was a hook that turned all this data into a list. They didn't have to worry about what the list looked like. So I guess that's one thing that's, have a little bit of an advantage over HTML, as you were saying before. This whole split between developers and designers. So here's our main page, .xaml. So this is Blend. This is what Blend looks like, right? And it loads. Okay, quick survey. Has anyone got a Windows phone? Hooray. Oh, that's not many. So people here, what do you use? Android? Yeah. And anyone with iOS? Okay. Interesting. So I'm guessing, because that was more than 100%, I think, so people have multiple phones. When you develop for, if you were to develop an app, would you develop it for all three? Yeah, anyone? Right, see, that's interesting. Because that's my experience as well. People that use Xamarin, just because it's sort of related to this, only use it for one platform. And the only reason they use Xamarin is that they can use C#. So the whole cross-platform, I don't know how relevant or valid it really is. But anyway, that was just an aside. So we have, you can see they're very similar, right? We now have all the different sizes here. It looks sort of like Visual Studio, but it's black. But once you click on things, then you actually get the properties on the right here. And it's much more of a visual way. If you try and write XAML by hand, you will go mad. It's a bit like Android development. It just messes with your head. So this is a way of doing all of this in a visual way. Now for this demo here, I'll just use this, and I might just make it a little bit bigger. There we go. So there's our canvas, right? It's going to be very exciting because I'm a great designer. So we can choose here, rectangle ellipses. We're just going to choose a rectangle, and we're going to draw that there. Look at that. Yeah? So that's Design 101. I'm going to make it blue. And then I'm going to draw another rectangle, put that here, and I'm going to make that the Ignite orange, or close enough. So there's my UI. I know that's not very exciting, is it? But what we want to achieve now is we want to apply some adaptive triggers. We want to change the visual state in a way that is independent of how or what device we're on. So this thing here, we're going to go up here and we can add a new state group. And in that, we can add a new visual state. And then we can add a, where is it? There. State trigger. So that was 3 clicks, and we can now add our adaptive triggers. So this only have the adaptive trigger, or the triggers for changing the visual state. You can write your own, and you can have a trigger on whatever it might be. Loss of network connection might be a good one. You can show a different panel, an overlay. You could have a trigger that triggers if you get out of a specific geographical zone. Like, you can really think of what could trigger this particular element to show or hide or change or whatever it might be. It's really that open. For this case, I'm just going to choose the adaptive trigger built in. I'm going to make this a bit bigger. So you can see we have now the min window height, min window width. And we're going to change this. Oh, by the way, don't forget to say this. You see the red border around it's very important. That means it's recording. So I'm now doing things for this particular visual state, which is over here. And I'm going to add this adaptive trigger. And I'm going to say that the min window, actually height is fine, min window width for this is going to be 500. So let's do 700. So that means that this state will trigger if the minimum window width is less than 700. Yeah? So, and then we're going to go in here and change the visibility to collapsed. Ooh, so it disappears, right? And then we're going to need another one. Actually, I don't think that's all right. So there's a visual state there. And the cool thing is that from blend, we can also run it. So I'll see if this works. So I got my logic mixed up. But it's all like that. If you haven't used blend, it's a really easy way once you sort of get around. There's a few quirks. One tip is always remove whatever default styling or styling that comes with it, because for some reason it always picks out something. Oh, I got the logic wrong. I got the logic wrong, but you get the idea. So now it's less than 700, then it shows. So if I'd done the other way around, it would have collapsed when I got less than 700. Anyway, so you get the idea? That's an adaptive trigger. It really is that easy. It's that quick to put on there. So, any questions for that? Yep. Yeah, that's right. So so you can target different properties for sure. So the actual trigger is written in C# in the code behind, and I can't remember off the top of my head, but you have it inherit from a certain interface, and then you use it in the same way you use the dropdown. It gets registered with the solution, and you can use it then as part of your solution, just the same way as I did it. And then it'll have different properties that are public, which is then what you fill in the form that came up, and then it'll do things, whatever those things may be, based on what your logic is. It's really quite straightforward. Okay, so, and then when I come back to Visual Studio, I've changed things, so it auto loads. Cool. Hey, there's a blob. Okay, back to slides. Is that 8? No, 5. All right. So that was the visual states. Of course, there are always edge cases. I mean, I'm kind of making it sound like it's really easy, and for the most part, it is. But an interface that works on phone and desktop may not work on Xbox, for example, at all. Like, you might want to change the way that the visual representation is completely. However, that doesn't mean that you can't use the same business logic, because that might still be the same data that you're showing. It might still do the same things with save and whatnot. So a way of doing that is a XAML view, as it says, custom device specific XAML pages. It's a way of alleviating the pain of having the same interface used on everything, but still allowing you to have majority of the same code running. Okay, quick demo. I know we're running out of time, but getting there. Okay. So, just open that. Waiting. So that makes sense, right? XAML view, yeah, cool. It's supposed to be pretty straightforward. Okay, Solution Explorer here. So we have in here in the views, we have a main page. And that main page has 2 panels. So we can see that down here. The grid has 2 text blocks. There's just a little load. One text block there says common main page. You can see that, yep. And then the other text block is actually set in the code behind. So in here. So this is set in code behind. So if you run this, hopefully, you can see that one gets set in code behind and the other one is just the one that you set in XAML, the static one. So this is probably a common scenario. You set some text that comes from somewhere and you bind it to a certain element on there. So this is all it is, right? Common main page, and this is set in code behind. Pretty standard stuff. So say we had a mobile version of this, and this particular page would make no sense on a mobile. So for demo purposes here, we'll go in here in the views, and we'll add a folder. And I need my cheat sheet, because the naming of this is very important. So you call it device, family, and then mobile. So you can probably guess, you can have device family of, I think there's 3 so far that it'll target. And then on that, all you do is you add a new item, and you then see here's XAML view. So that's what a XAML view is. And you have to name it the exact same thing. For some reason, Visual Studio doesn't like that by default, but you have to name it the same. So it's so that the compiled code knows that they're the same thing. And you add that. So now it's in here. So I guess the peculiar thing that you may notice or may not is that there's no code behind file. So this is just a XAML page. There's no, like it's down here, .cs. There's none of that. It's just a main page.xaml, which can really lead to confusion up here because you can't remember which is which. So that's our standard one, and we're just gonna take this grid. We're gonna copy everything. There we go. And here's our thing that has nothing, and we'll paste that in there. And then we can say in here, we'll just call this mobile main page. So you get the idea? So now when that loads on a mobile, yep.
Sorry, are they both in the same namespace?
Say again?
Are they both in the same namespace?
Oh, God, good question. I believe so. Yeah. Already declared. Well, yeah, as you'll see. Because the logic is that it'll know which device you're on and it'll look specifically. That's why the naming of that folder is so important. So we'll run that. Oh, it's going to run on desktop now, isn't it? So this is still the same. See, that still goes. Now, because it's a different machine, let's see if I actually have the mobile emulators on here. Oops. Yay, I did. Okay, hopefully this is not going to crash. So, any questions? Because this may just take a minute to load up. Yep.
Is this compatible with a lot of the MVVM frameworks like MVVM Lite or Prism or any of those sort of things?
A very good question. Is this compatible with MVVM frameworks like Prism, or MVVM Cross, MVVM Lite, any of those? Yeah, for sure, absolutely. Because you're not fiddling with the code behind. All your logic and the code behind is the same as you'd write for a phone or a tablet or whatever it might be. It's only your UI that really is what we're talking about. Does that make sense?
So all the views will still find the same view model?
Yes. Yep. No, they should. And there are a specific version of, okay, bugger. Not enough memory. Hooray. This is a Surface Pro 1. So there you go. Anyway, one demo fails, not too bad. So that's the idea. You have a XAML view and you can use that if there is, such as your client, to say, well, hang on, this experience might be the same data that's coming in, but on an Xbox, we want it to be completely different branding or completely different layout or whatever it might be. So Where are we going? 5. Cool. Okay, so reasons why you should do this. Speed. You can develop for more devices a lot faster by using adaptive UX because you are just fiddling with the UX once. You don't have to reimagine for the next device, and next device, and next device. Capitalize on your work. So you get rewarded multiple times for slightly less more than one time the work. This is a big one for me, maintenance. Maintaining Android projects, I keep picking on Android, but it's just a good example in this case. But maintaining Android projects, and it could also be having a Win32 app and a mobile app, and having multiple target platforms and maintaining that code is an absolute nightmare. Does anyone here know what I'm talking about? Please raise your hand. Sure. Yeah, exactly. The maintenance part of this is if you do your code right, as always, we want clean, nice, efficient code. But the maintenance is just, there's so much less maintenance, it's not even funny, because you're just managing one code base, which gives you more time to build features, which is what we all want to do. Like, I don't know any developers that go, yes, I get to fix that bug. It's fine once in a while to make sure things are running smoothly, but we want to build new things, right? And then, of course, come on, there's this. I don't know if you've seen this slide before. You might have seen this in one of the other presentations. But that's the aim. There's 1 billion devices running Windows 10 in 2 years, 3 years, thereabouts. We're at, 120 million now, I think, something like that, after about 4 months. But this includes everything, right? There's 1 billion devices, not 1 billion phones, it's not 1 billion PCs. This is 1 billion of Windows 10. And the adaptive UX will work on all of those. But this also includes, as you see at the bottom, there's web, where you can wrap your web project in a, what's it called? I forgot what it's called now. Hosted web app. And you can add features like notifications or using the camera, or you can have your website running as an app, but adding platform-specific features. These are all the bridges, by the way, if you heard of the Windows bridges. Now, this one still has Android on it because about 2 days ago, there was lots of rumors about Android having got cut. But essentially, it was a way of using your Android APK package and dragging it into your developer portal and then getting, I'm not sure if you've got the code out for a Windows 10 app or just published as a Windows 10 app. But I'm not sure that's happening now. There's rumors, I really don't know what's happening with it, but there's rumors that it's been cut. .NET and Win32, still you can wrap it for the universal platform, and the same with iOS, which is on GitHub. If you want to play with the iOS project, I know none of you said you are iOS developers, but you can use that code to push out to Windows 10. So there's a mapping between the APIs. There's actually a lot of really clever stuff. That's a big one for me, is a reason to start looking into this sort of stuff. Don't forget to complete the session evaluation, please, because that means you win stuff, essentially, hopefully. And if you've got any questions now, please. I'm here for another, 10 minutes? I know we talked about questions overall as we went through, but yeah, sure.
If you still need to support, as actually we would at this stage, Windows 8 platforms as well, is there any of that technology that sort of can make your life easier?
If you still need to support Windows 8?
Yeah, and
no. Not really. I think Microsoft is really interested in you moving to Windows 10. Hence, it's a bit clunky even changing projects from Windows 8 to Windows 10 because it just is so different. You have universal apps for Windows, which work on phone and desktop, but that's about it. That's kind of where it stops. So, anyone else? No? I can't see any. Just yell out. No? Fantastic. Thank you very much, guys.
Don't you think that it's boring how people talk? Making smart with their words again. Well, I'm bored. Because I'm doing this for the thrill of it, killing it, never not chasing a million.